IT disruption as usual. Yeah, so this webinar is around the case study for 1450 degrees C rated green fiber for insulating ethylene furnaces. By green fiber, we mean a fiber that is not classified as hazardous according to the existing legislation. So this will be the agenda, showing you who we are and what we are doing, then discuss a little bit about the ethylene crackers linings, as well as introducing you the case study and our Superwool XTRA. Then my colleague Nicola will have the health and safety and environment session. And then again, we will go in more details around the Superwool XTRA as well as the case study. And as anticipated by Dominica, we will assign at some time for questions. So within the thermoceramic, we have a team of experts that are focused in the petrochemical applications that are available to support our customers globally. Start with myself. My name is Riccardo. I'm the Global Petrochemical Market Manager, and I'm based in Italy. Then we have Nicola Robinson. She is our Regulatory Compliance Manager based in the UK. Steve Chernak, Global Technical Manager, as well as Steve Yardley, who is the Petrochemical Technical Manager for Europe, who is based in the UK. Our company, Thermoceramics, manufactures an extensive range of high temperature insulating products, and we do also design systems for such thermal insulations, typically in high temperature environments. Our broad product portfolio consists of fibers in different forms, from blanket to modules to vacuum forms, mastics, as well as insulating board, but also includes the castables as well as insulating fabric, and also specific material for passive fire protection application. Our products are renowned to help customers, especially those operating in processes involving high energy, so energy intensive. And our aim is to reduce the energy consumption, to reduce the environmental emissions, as well as helping our customer to reduce their operating costs. We do that not only with materials, but also we offer engineering services in order to develop state-of-the-art solutions for the bespoke applications that our customers might have. We are based globally, and we have a global footprint. We have 36 manufacturing sites spread across the 5 continents. Now, if we speak specifically about ethylene crackers, which is the typical design, well, the lining design is typically composed by high temperature refractory ceramic fiber, typically in modules, so rated up to 1430 degrees C. There are also insulating fabrics, as well as castables, typically on the floor. If we concentrate a little bit on high temperature fiber, this is quite a common product used for insulating ethylene crackers. In fact, there are many cracking furnaces lined by RCF that are in need for a revamp. The problem with the refractory ceramic fiber is that it's under ever increasing scrutiny from health and safety perspective, and its use has several restrictions, especially in Europe. But Europe is not the only continent where we see those restrictions, as many other countries now are regulating RCF in both its green and fired state. There is also another high temperature fiber that is available, what is called the polycrystalline wool, which is a high alumina blank fiber. It's rated 1600 degrees C, but the price is much more expensive typically than RCF. So as a company, we identify the gap, and the gap is there. There is no cost-effective, high-temperature, low biopersistent fiber to replace the RCF. And most of the low biopersistent fiber in the market, they have a too low classification temperature to be used in ethylene cracker, because their classification is up to 1300 degree centigrade. Actually, we faced that gap a few years back when a European petrochemical market leader was coming to us to solve a problem they have. They have several ethylene cracking furnaces, and which roof is lined by RCF fiber in the typical module configuration, meaning 300 millimeter of refractory ceramic fiber modules with a backup pipe blanket. The point is that being in Europe, the health and safety regulations is no longer allowing the use of RCF. And therefore the customer requested us an health and safety compliant lining concept. Now we said, okay, is there any technical alternative to fiber for that? Sure, there are. There are alternatives, but they are typically heavier, and also they are less efficient options for revamps. And those consist in insulating fabrics with a backup pipe block, as well as castables. But both have a problem because they are heavier. Also, with bricks is also harder to design and install, and castable is even much heavier. And also, the anchoring system is quite expensive. Plus, there are also safety issues because if you enter the furnace after years of operation, as you know, you might experience to have some cracks, and therefore some area is not really stable, and therefore we might have some issues for the operators to get inside. In addition to that, also, if original crackers are designed to be fiber lined, of course, also the structural steel load is less. Therefore, if you are switching from one type of lining material to another with higher weight, then the load might be too high without a structural modification. And as you know, a structural modification for a unit is quite complex, and we don't really want it during a revamp. So we really needed a fiber option in terms of preserving the original weight, have a similar efficiency, and also to still allow a faster cycling of the unit. We know how important it is to have the furnace up to operation in the minimum time. That would mean a lot for the end users. And also that would mean also there are less operational changes. So is the above all the options that we have? No, not really. We have now the most appropriate option that is available to replace the 1430 degree C rated RCF. And our solution is this Superwool XTRA that we will be discussing in more details in the next slide. But before doing that, we'd like to reply to some questions that might be of interest. Why there is a need to change those RCF materials? Why are regulators so concerned about the use of RCF? As we will see, there are several good reasons. And my colleague Nicola will now explain you all of these good reasons in the health and safety section of the presentation. So Nicola, over to you. I think she's muted.
Hello, can you hear me now?
Yeah.
There we go. So, as I was saying, history shows that where you have fine asbestos fibres that can be inhaled into the lungs, they have the potential to cause cancer. It's important to note that RCF and man-made mineral fibres in general are not asbestos. if you look at the two pictures, the one on the right-hand side shows asbestos. And what you have with asbestos, because it has a crystalline structure due to the way it's made in nature, it cleaves along the length of the fibre, so you end up with thinner and thinner fibres that retain the same length. With man-made mineral fibres, you get breakage across the fibre length, so that you end up with shorter fibres that retain the original diameter, and they become broken down sufficiently that the lung's natural mechanisms can clear them. There are differences, however, and RCF does have a higher biopersistence than most glass walls and mineral walls. Biopersistence is basically a measure of how easily a substance is cleared from the body by its natural mechanisms. So the higher the biopersistence, the longer it will stay in the body. This means that it doesn't break down into short fragments as easily as some other fibre types, for example, superwool. And when animal testing was carried out on RCF in the early 1990s, it did show signs of carcinogenicity. Human epidemiology has shown that there is a reduction in lung function among smokers exposed to RCF. So the ability of the lungs to take in air is reduced. And there's also a correlation between pleural plaque development and cumulative RCF exposure. There has been no incidences of statistically significant lung cancer in the human epidemiology studies. And when we look at pleural plaques, these aren't in and of themselves markers for disease. They're not specific to fibre exposure. They can be caused by pneumonia, as well as other types of dust exposure. What they are is evidence that the body has interacted with foreign material for extended periods of time, and obviously that's of concern. In Europe, the fibres are regulated under the carcinogen classification, labelling and packaging regulation. RCF is classified as a category 1B carcinogen, and it also has a binding occupational exposure limit value under the Carcinogens and Mutagens Directive of 0.3 fibres per mil. And we'll talk about why that's important in a couple of slides. The low biopersistent family of fibres, which includes Superwool Plus, HT and Extra, are all exonerated under the CLP regulations using Note Q testing. This basically means that they're exempt from classification because there's sufficient evidence of low toxicity. Polycrystalline wool, the other fibres that Riccardo mentioned earlier, are self-classified by the REACH registrants as non-hazardous. They do not have a harmonised classification in Europe. And then finally, crystalline silica. It doesn't currently have a harmonised classification in Europe. However, recently process-generated respirable crystalline silica was added to the Carcinogens and Mutagens Directive and also has a binding occupational exposure limit value of 0.1 milligrams per cubic metre in this case. So what does that mean in practice? For refractory ceramic fibres, this classification as a category 1B carcinogen sets out, triggers certain legal obligations. Under the Carcinogens Directive, substitution is required with a less dangerous alternative where it's technically possible. If substitution is not possible, exposure should be reduced to the 8-hour time-weighted average occupational exposure limit for the relevant country or the binding occupational exposure limit value. When handling waste, it should be bagged, labelled and disposed of at landfill specialising in hazardous waste. And if risk assessments show that there is the potential for risk to health or safety following exposure, worker health surveillance should be carried out. That has to incorporate both workplace exposure monitoring as well as occupational health surveillance, which would include, for example, lung function testing. In response to these regulations, the Superwool products have been developed over time. Superwool Plus, HT and Extra are all exonerated from classification as carcinogens based on animal test data and are treated as non-hazardous substances in Europe. We continue to develop our low biopersistence range and work closely with the Fraunhofer in Germany, who are an independent testing laboratory, to ensure that our products meet the European exoneration criteria. We demonstrate this by passing one of 4 animal tests that are laid out in the note Q of the classification, labelling and packaging regulation. And proof of exoneration should be available before a product is put on the European market. Thermal ceramics utilise Fraunhofer testing as part of our development process so that we ensure we are fully compliant with all regulatory requirements before we place the products on the European market. When we look at workplace exposure, since the introduction of the binding occupational exposure limit value, there is much more alignment between the European countries. The range is now between 0.1 fibres per mil up to 0.5, with the most frequent being 0.3 fibres per mil. When we look at that kind of level, when we do monitoring at workplaces, we typically see that for around 80% of measured installation operations, so where we're actually installing refractory ceramic fibre into furnaces, into end-use applications, the measured fibre concentration exceeds the 0.3 fibres per millilitre limit. Once you reach 0.1 fibres per mil, it's difficult to maintain that level of control without reliance on respiratory protective equipment. And we use a lot of workplace exposure testing to properly map what the exposure levels are. As I mentioned, with installation and removal operations, they're amongst the highest exposure job categories, often in excess of 1 fibre per mil. Obviously, engineering controls are difficult to implement in this kind of situation because they are transient, short period, and often quite large scale. Once the product is installed and in the end application and is in use, the applications are typically very low. Fibre insulation is not disturbed during normal running, so we would typically expect the levels to be less than 0.1 fibres per mil. We're now going to talk briefly about crystalline silica. So crystalline silica is found in a number of as-made products, including some vacuum form products, IFBs and castables. And what we find is that during use at high temperatures, RCF and AES fibres will devitrify and form stable crystalline phases. The phases that are formed depend on the chemistry of the fibres, and after service RCF fibres do contain crystalline silica bound within the amorphous glass matrix. Superwool XTRA is different. It has a different chemistry, and it means that when it devitrifies, it does not contain excess silica. So that means that no crystalline silica phases are formed. When we look at a furnace lining, it's important to remember that it doesn't completely crystallize all the way through. Only the hot face temperature, where temperatures are above around 900 degrees C, will see a level of crystallization, and that crystallization will increase the higher the temperature and the longer the duration. What we do see is that workplace monitoring shows that during removal operations, even when the I'm just seeing that there's a sound issue. Are people able to hear me at the moment? Okay, so hopefully it's just a few of you that are having problems. Good. Apologies to those that can't hear me, but for everybody else, I will carry on. So, as I was saying, during removal operations, when the fibre levels are very high, we still see that the levels of respirable crystalline silica in the dust remain low. The degree and extent of crystallization will depend on that duration and maximum use temperature. With Superwool XTRA, we've carried out extensive testing, more than 7,000 hours at 1250 degrees C. And what you can see on the XRD trace on the right-hand side is, if you look at the green and the red lines, these are the traces for quartz and cristobalite, which are the two most common forms of crystalline silica. Distinctive peaks. When you compare this to the Superwool XTRA traces, you'll see that there are no equivalent peaks on the traces. So this means that we can show that Superwool XTRA's unique chemistry excuse me, sorry, means that there's no free silica available to form crystalline silica during use. That extensive testing does include third-party testing, which reports are shared on our website. I'm now going to hand back over to Riccardo, who is going to go through some of the more technical information on the case study. Thank you, everybody.
Thank you, Nicola, for your session on health and safety. It's thank you for highlighting the importance of being health and safety compliant and why the regulators are now having higher scrutiny on RCF. Now, let's go through about our innovative new low biopersistent fiber. This is designed for these unique high temperature applications that not only address the classification of not being carcinogenic, but also the respirable crystalline silica, as Nicola anticipated. So, which is the best fiber products form to be used in ethylene cracker lining? Well, it's actually a fiber module, and to do that with our Superwool XTRA, what we do, we start from the blanket. We cut the blanket in strips, we then embed the metallic hardware, and we compress the fiber in order to compensate the shrinkage during the operation, and we get what we call a stack module. A stack module that is then installed typically in a soldier pattern. Now, why modules as prefer to blanket laid options in ethylene crackers? There are several good reasons. First of all, we want to create high compression once the bending strip are removed, and that means the lining is less susceptible to shrinkage gaps. Also, in a modular system, there is a better resistance against mechanical abuse in specific applications and zones, such as the door seals. Also, the resistance to the hot gases velocity is higher, and that is also verified by tests that we have done and of the results that we have achieved. And also, the metallic hardware being embedded in the module is not exposed to high temperature, meaning the lining is safer over time. On the design itself, I mean, who's going to make it or to develop a design system? Well, we can do that at Thermoceramics. We are considering, of course, the operating parameters. We are considering the applicable standards as well as the specifications. and of course, any additional need that our client might have in terms of insulation, in terms of ease of installation, in terms of longevity. I mean, there are several criteria that we can use while designing a lining system. Is the installation method different for Superwool XTRA modules? Actually, no. The installation of Superwool XTRA fiber module is the same as RCF modules. Therefore, that means there are less risk during the installation phase. And we are going to provide the required installation instruction, and we can also assign one or more supervisors as required in order to assist during all the steps of the application of the modules. Also about the maintenance, is that different? Not really. As any fiber module lining, also Superwool XTRA needs some regular maintenance. And again, we are available to support our clients in assessing the lining performance and provide expertise on potential improvements as they require. Specifically for XTRA, is it working in an ethylene cracker? Yes, it does. Actually, in 2015, we substituted the RCF lining of that ethylene cracker roof with Superwool XTRA modules, and we use as a backup the insulating board, insulating blocks. The reasons for that is that customers wanted a flat surface against which attaching the modules, and therefore they prefer to have insulating board. And the follow-up actually was very positive. The client was very happy with the performance of the Superwool XTRA. Also, they were running tests on the formation of respirable crystalline silica, not only on that extra lining, but also in the other linings that they had installed in their units, and there was no detection of this respirable crystalline silica in the extra lining. Therefore, absolutely, we are delivering what we promise. And because of all this positive testing and experience, now the client is considering to reline all the remaining furnaces that they have with Superwool XTRA modules. So install this all of their crackers. Here are some pictures during the installation. So you can see the module and the button strip in between. So really a conventional installation that should be also done in an appropriate manner by an experienced installer, because it's not different in concept from the RCF lining system. Of course, the fiber is different, but this will not affect the performance during the installation. Do we have references also for other zonal crackers? Yes, we do. We did several Superwool XTRA lining system over the past years in ethylene crackers, and all have been with successful results. So the current operation installations are the first radiant roof that was done in October 2015. Then in 2017, we did a shadow box relining in the tube passage area. Then again, the same year, we aligned the transition section of a cracker. And the next year, 2018, we have done another roof lining in the original plant where we tested XTRA initially. So as a proof that client was happy about that. So let's say XTRA is a reliable product that can be installed in an ethylene cracker. These are also some pictures of the transition section. Same configuration again, so it shouldn't be a surprise to the installer, with again modules and the button strip. This is indeed the sketch of the engineering we did for the shadow box area. So we are going to design and manufacture this area and provide modules cut as per the openings, as per the coils configuration. So we are going to provide a bespoke design for the extra modules in order also to have, of course, safe operations and taking into consideration the elongation of the coils during the operation of the equipment. But this is something that we can do as part of our package. So we have several references. This is a summary of the 4 projects that we did for ethylene crackers, starting from October 2015. We have also done other applications in the petrochemical business, mainly for ammonia and hydrogen reformers, as well as ground flare. But we have also experiences in other markets, like the iron and steel. And why we are mentioning here a case of the forging furnace? Well, because it's still a high temperature operation, up to 1280 degrees C. It's a cycling process. It's a very polluting and corrosive atmosphere. And also there, we had very good results. We started with a small wall panel back in May 2015. Then the customer decided to extend the installation next year to half a roof, and then we went for full relining. So the product is available and is referenced for the high temperature and also for very harsh conditions. So we are now open to take questions, any question, comment that you may have. Thank you for your attention, and please, if you have any doubt, please raise it.
Please remember to post the questions just below the screen in the question area. Okay, so far no questions. We're gonna wait a few moments if any other appears.
So there's,
yeah, of course, yeah, we are available to support you as you require. So we'll be sharing our contact details. So if you have any question in future or any further need of clarification.
I think, Riccardo, we got one question on the chat. So if you could take a look.
So why modules made by stack and not folded blanket? Yeah, so it's in the case of the extra fiber, let's say we have seen that the stack is the most performing for a modularized system. Therefore, that's the one that we are using. Also, it provides a more uniform surface for the modules themselves. So that's why we use the stack module configuration.
Okay, we have another one on chat and 3 more in the question area.
Yeah, so do you have talk about high temperature furnaces? Do you have application in regular refinery furnaces as well? Or there are no economic or technical incentives for these furnaces? Yeah, so that depends on the application, on the operating conditions. Typically, let's say for the refinery heaters, the application temperature, the operating temperature is lower, and therefore, let's say with the other low biopersistent fibers that we do have, like the Superwool HT or the Superwool Plus, that their classification is up to 1300 degrees C, that classification temperature typically fulfill the requirements. But we are now in discussions with other clients where anyhow they want a classification temperature of 1430 degrees C for the fiber, and we are proposing extra also for those applications. As those units are not yet in operation, we have not listed them in the references, but yes, there are these ongoing for having refinery units aligned with Superwool XTRA as well.
both on chat and on question area.
So for what kind of furnaces is XTRA not possible? I would say that XTRA is not possible for furnaces where the use of fiber is not recommended. Typically, let's say for it can be used where the RCF fiber can be used as well. Therefore, where fiber is not recommended, then of course that applies also to XTRA. There might be also some specific installations with a certain chemical environment, but those, let's say, are quite limited, especially in the petrochemical business. So basically, yeah, where fiber is not recommended, that also the limitation apply to XTRA. Can I use the same thermal conductivity for RCF to XTRA to make the thermal profile? Well, actually, the XTRA has different conductivity. Anyhow, let's say for we are able to support you to have the right system, but there are data sheets available with the thermal conductivity values for the Superwool XTRA modules in order for our clients to define the lining design. But again, we are available, let's say, to design together a system in order to obtain the desired thermal profile or insulating values that you want to achieve. Consider also that we are continuously working to have the conductivity improved. So as a company, as for any other fiber that we did, we are also enhancing the process in order to continuously lower the conductivity. And those values are now reflected in our data sheets. So, okay, the other one is XTRA much more price expensive than RCF? Yeah, I mean, it depends on the configuration. So as I said, let's say we consider the whole system. So we are available to develop a specific option with our client for the specific design conditions, considering the overall system, and provide you a detailed quotation for that, depending on the type of hardware that you need, etc., and the densities that are required. So, yeah, one question. Any project reference in Middle East for this product? Not yet, but some are under preparation, and therefore, let's say, as furnaces are not yet in operation, there might be references in the future. The references done are for Europe because there the legislation is stricter, and therefore there is where we started with application of the Superwool XTRA, and therefore why most of the references are there. So when will Superwool XTRA be available in Canada? Actually, is available in the sense that we are manufacturing it, and we can ship it where required. So let's say you can receive our goods also in Canada, if based on your requirements. The other one is, yeah, is it usable in continuous and discontinuous furnaces? We have some application where there are cycles, so the process is in cycles. Of course, yeah, it depends on the duration, the length, and the type of cycles. But in principle, yes, it has been working. XTRA has been also tested in cycle units like the forging furnace that I mentioned in the references. You can share the material data sheet for XTRA, absolutely. I think it's available on our website, but you can email us if you need that, so we can send you also the link or even the document. That's not a problem. All the documentation is there, starting from material data sheet up to material safety data sheets. So we do have the technical documentation that is required. So what point is, what shrink roll expansion are you seeing in use? So yeah, in use, let's say the shrinkage of the fiber is compensated by the compression, as for any other fiber material. So what we are seeing, this fiber is slightly expanding as well. So after the initial contraction, the fiber expand a little bit. So let's say, even in the cold state, in some cases where you see some gaps, those will be filled by the expansion of the fiber. We do have a video that shows that as well, and we are more than pleased to share that. So that point, yeah. I think there was one, Nicola, on the health and safety.
I think this was the one that is already answered from Dean. I think Dean didn't notice the comment. Superwool now considered LBP, not IES. If you could.
Okay. So yes, because of the unique chemistry of XTRA, it doesn't fall within the chemistry definition of AES. So we're now using LBP as an umbrella term for all the low biopersistent fibres. AES is still applicable to Plus and HT because they fit into that chemistry bucket.
One more new one from William in the question area below.
Yeah, so Superwool XTRA stock in Barrington, Ontario, or Augusta, Georgia. It's we have several stocks. Most of it is in Europe, but yeah, as I said, we can ship it over as required.
Yeah.
Yeah. So I said, other than environmental compulsion, is there any other plus point to recommend XTRA over regular RCF module? Yeah, that's depend on resistant to some pollutants. For instance, for the furnace, the performance of XTRA was much better. But yeah, so it depends a lot on the application. But let's say for the petrochemical business, especially for ethylene crackers, then let's say the application is very safe, can be applied without any problem.
Okay, so Dean was asking specifically about chemical resistance of XTRA.
Yeah. So yeah, we do have a series of tests done on the various pollutants. So we can share that document, those results with you. It's not a problem. We did the testing with several pollutants, and we compared also the resistance with the RCF. And in most cases, there is a superior use resistance. Okay, if I'm not mistaken, we picked up all the questions. If there is any that we have forgotten, please raise that, or again, we are available for support and reply to you. Okay, so yeah, as a conclusion, so Superwool XTRA is exonerated from carcinogen classification, and that is certified by a test result issued by the Fraunhofer Institute. The modus and blanket have a 1450 degrees C classification temperature. It does not form respirable crystalline silica because chemically there is no free silica to do that. The module system is working well continuously at 1250 or 39 degrees C. There is no problem with the high velocity gas impact, and we have the successful references since October 2015. And there is more and more, there is a trend where more and more companies are replacing RCF with green alternatives, as there is now an available solution for that. Again, we really thank you very much for your participation to this webinar. I mean, here are our contacts. We are really more than pleased to give you our support and reply to your questions and provide you with additional documentation as required. So as I said, please contact us, and we will be more than pleased also to organize specific session for you depending on your needs. We do have a lot of experience and materials available that we are happy to share with you. That's it again. Thank you very much, and please stay safe. And I look forward to meet you soon and sometime.
Recording will be also available for you after the session. You're going to receive an email with the link. Thank you very much again, and have a great rest of the day.